Hello friends, I am Professor Pratap Enshinde. Welcome you for the lecture series of engineering mechanics. Now we are dealing with the problems of non-concurrent force system. So in front of you there is one numerical from the Beer-Johnson. This non-concurrent force system. So parallel force system. So one category of non-concurrent force system is the parallel force system. So let's start this numerical. So first read out the statement of this numerical. Here it is mentioned that two children are standing on a diving board of mass 65 kg, knowing that the masses of the children at C and D are 28 kg and 40 kg respectively. Determine the reaction at A and the reaction at B. Okay. So first understand the meaning of the statement. So here in this problem, it is mentioned that the mass of the board is given. The mass of the board is given 65 kg. This whole mass of the board is 65 kg. So always you know that the mass of board is always passing through the or any material is passing through its CG or center of gravity. So the mass of this board is passing through this point G, and the two persons are standing at a point C and point B. The person C is having weight 28 kg and the person who is at point D having the mass of 65 kg. And two supports are given to this board. So one at A and another will be at B. If you observe this support A and support B, you find out that at point A there is a hinge support, and at point B, if you observe this point B, it will provide the roller support to this standing board. So this is given problem. Now first step, while solving the problems of statics, try to draw the free body diagram. What is free body diagram? Which shows all active and reactive forces, and it is isolated view of the body. So first we have to draw the isolated view of the body which shows all active and reactive forces. So I have isolated this flying board from its support A and B, and I have to show all active and reactive forces. So what are the active forces? The forces active are the weight of the persons. So that weight of the person is standing at point C, 28 into 9.81 Newton. I have converted mass into weight by multiplying by 9.81 Newton. Similarly, 40 into 9.81 is the weight of the another person which is standing at point D and which is going in downward direction. The weight is always acting in a towards the earth, or we can say that in downward direction. The mass of the flying board is given 65 kg. It is acting at CG of the flying board. The flying board CG is also given at a distance of 1.6 meter from point D. So this mass is 65. So I have converted it into weight. 65 into 9.81 is the weight of this board. So these three are the active forces which is acted on the board. So reactive forces. So at point B there is a roller support. So all of you know that the reaction offered by the roller support is only one reaction which is perpendicular to the point of contact. So reaction offered by the roller support 1. So I have noted this reaction by the symbol VB or by the notation VB. Now here the type of support is hinge support. As point A there is a hinge support. So reaction offered by the hinge support are the two reactions. One is in X direction and another one in Y direction. Therefore, I have replaced this hinge support by its two reaction. One is the VAY, that is reaction in vertically upward direction, and the another reaction is VAX, which is horizontal in direction. And the distance I have written by the help of this pink chart. The distance between C and D 1 meter, the distance between D and C is 0.6 meter, the distance between D and G is 0.48 meter, and the distance between A and B is 1.2 meter is given. Okay, so once the free body diagram is over, the next step is we have to apply the condition of equilibrium for non-concurrent force system. Non-concurrent force system means the forces which are not meeting at a single point. Okay, so what are the conditions of equilibrium for the non-concurrent force system? There are the three conditions of equilibrium. First condition is summation of all the forces in x direction will be equal to 0. That is nothing but the summation of f of x is equal to 0. Second condition is summation of f of y is equal to 0. Means summation of all the forces in y direction is equal to 0. And third condition is that moment about any point is equal to 0. That summation of moment about any point is equal to 0. This is the third condition of equilibrium. Okay, let's begin with the first condition, summation of f of x. So if you observe this free body diagram, how many forces are there in x direction? Yes, there is only one force, that is VAX is in x direction. Therefore, VAX is equal to 0. So we are able to find out the reaction offered by the support at A, that is VAX is equal to 0. It is quite simple because there is no inactive force in x direction. Therefore, VAX is equal to 0. Now we have to apply the second condition of equilibrium. What is the second condition? Summation of f of y is equal to 0. That is summation of all the forces in y direction is equal to 0. So now let's plug all the forces in y direction. So what are the forces in y direction? So if you observe the free body diagram, you will be able to find out the forces in y direction. Okay, come across the joint or the support at A. The one reaction is VAY in vertically upward direction. Another reaction offered by the roller support, that is VB, in vertically upward direction. So both are in vertically upward direction. At G there is weight or mass of the standing board is concentrated, so that is in downward direction, and these are the weight of the two persons which is standing at point C and point D respectively. Okay. Now we have to plug all the forces in y direction. So here I have assumed that while writing the equation of summation f of y, assume that upward is positive. Okay, sign convention. So here VAY plus VB both are positive because it is acting vertically upward. Minus 65 into 9.81 minus 28 into 9.81 minus 40 into 9.81. These three carry a minus sign because they are vertically downward direction. Now if you simplify this, you will get an equation VAY plus VB is equal to 1304.73 Newton. Let's say that this is my equation number 1. Now we are having these two equations VX and f of x and f of y. From that we cannot able to solve this problem because there are the three unknowns. So we require the one more equation, that is third equation of equilibrium, that is summation of moment about any point is equal to 0. Here for simplicity I have choose the point A for taking the moment. So always remember that where is the maximum number of unknowns, at that point you have to take as a moment center, or you have to choose that point for taking the moment and equate it to 0. Okay, so I have considered the moment about A. So first, what is moment? Moment is nothing but the force into perpendicular distance. So now if we want to take the moment about this point A, let's begin with the VAX. VAX into perpendicular distance 0, exactly, because this force is passing through point A. Now the second force VAY, which is again passing through the point A. Therefore these two forces not create any moment. So moment created by the supports at A will be equal to 0. Now come towards the next support VB. This is the force VB into perpendicular distance. Distance between point A and B is 1.2. So VB into 1.2, and if we observe that create the moment in anti-clockwise sense, our sign convention anti-clockwise is positive. Therefore, positive VB into distance 1.2. Then next, 65 into 9.82, that is 637.65, and the perpendicular distance between weight of the flying board and A, the distance is 1.68. So 1.68, 637.65 into 1.68. Again next, the weight of the person at C and the perpendicular distance between A and C. The perpendicular distance between A and C is 2.28 and weight of the person is 274.68. That is force into perpendicular distance. Again, force into perpendicular distance, that is the distance between point A and D is 3.28. All the three carries the negative sign. Why? Because if you observe that these three forces will create the moment in clockwise sense. Our assumption is clockwise minus, anti-clockwise plus. Therefore, they are carrying the negative sign. If you solve this, here in this equation only one unknown is VB. You are easily get that value of VB. That is 2487.162 Newton. Once VB is known to us, substitute the value of VB in equation number 1. So here, if we substitute the value of VB, we will get the value of VAY. So VAY 1182.432 Newton. So VAY is known to us. Now we have to find out VA. So how to find out VA? We know the formula. VA is equal to under root of, or the resultant is equal to summation of f of x square plus summation of f of y square. So here VA is equal to under root of VAX square plus VAY square. Here VAX is 0. So simply this square and square root get cancelled. So you will get VA is nothing but the VAY, that is 1182.432 Newton. Thus we are able to find out the support reactions of non-concurrent force system, or the problems of beam reaction. We can say that are problems of parallel forces. Okay. So thank you friends. We will stop here and we will meet in the next lecture. Again we are going to solve the one or more numericals on beam reactions or the non-concurrent force system. Thank you very much.